Today we are going to talk about the basic knowledge of scientific notation to make sure that you understand how to put a number into scientific notation. That's our goal. Why do we use it? Well, we have lots of small and large numbers in chemistry. For example, the number of atoms in a mole is this big long number here that starts with 602. All right. So how many zeros are there? Well, frankly, I don't want to count them. I have counted them to make sure the number's right, but it's a lot of zeros. And how about Planck's constant? Planck's constant is a very, very small number. Planck worked with Einstein, and you'll notice this is a very, very small number because there's a decimal point here. All right. So we have numbers where we have lots and lots of zeros, and it's real easy to mess them up. So instead, we could count numbers and figure out where decimal points go and multiply it by some big number, like 100 million or a couple of billion or whatever. All right. It also helps with significant digits, which we'll call significant figures, but we're going to learn that in chemistry. All right. So you don't have to worry about that right now, but we'll get there later. Right. Exponents. Notice that 10 to the 4, what that means is you're multiplying by 10 4 times, which is 10 times 10 times 10 times 10, which happens to be a total of 10,000. 10 to the 3 is 10 times 10 times 10. There are 3 tens there. It's 1,000, etc., etc., etc. One of the ones that really bothers my students a lot is 10 to the 0, which means you're multiplying by 10 no times, which means you're multiplying by 1. All right? So 10 to the 0, actually any number to the 0 is always 1. So you have to remember that. All right? And these are just things, again, I'm not teaching you stuff. You should already know this. It's just kind of refreshing at your head. Okay? 10 to the minus 1 is 1/10, 1 over 10, which is 0.1. 10 to the minus 2 is 1 over 100, or 0.01. 10 to the minus 3 is 1 over 1,000, etc. So you're seeing a pattern, right? One of the things you should notice, for example, with this 10 to the 4 is I move my decimal point essentially 4 positions to the right. You'll notice if I started with 1 and I went 1, 2, 3, 4, I've moved my decimal point 4 positions to the right. Here I've moved it 3 positions to the right. Here, let's go all the way to the bottom. Down here, I've moved it 4 positions, 1, 2, 3, 4 positions to the left. Right? Now, it's real easy to get confused of left or right, which way am I going? All right? And that's why I like the concept of looking at something like 10 to the 4 and saying 10 to the 4 is a big number. It's 10 times 10 times 10 times 10. All right? So as a result, it's a big number. Right? So if I have a positive exponent, that means I'm multiplying by a big number. Okay. So let's look at converting between scientific notation and standard notation. You can go either way. All right? But here I have 5.32 and I'm multiplying by 10 to the 1. All right? Well, that's like multiplying by 10, and you'll notice I have 53.2. Notice all I had to do was say, well, I'm multiplying by 10. I'm going to convert that to 53.2. I'm going to move the decimal point 1 position. Right? So what I'd like you to do is pause the video, do the next two on your own, and see if you can do them. Okay? So you should be able to look at this and say, I'm moving the decimal point 2 positions, so I should have 476. Do I believe that? Well, 4.76 times 10 to the 2 is I'm multiplying by 100. All right, and if I multiply by 100, I'm going to get 476. Down here, I'm going to multiply by 1,000. So that means I have to move my decimal point 3 positions. There's 1, there's 2, and now I've got a problem. I have to move it 3 positions. What in the world do I put there? Well, I put a 0 right there. All right, so this number is going to become 8440. And something we're going to be talking about in chemistry is you're making up that number. All right, so you don't know if it's really 8441 or 8442, but you're making up that number. So we'll talk about that later when we hit chemistry. Bottom line here is you move the decimal point 3 positions. All right, here's another one where we're multiplying by 10 to the minus 1. Well, that tells me instead of multiplying by 10, I'm multiplying by 0.1. So I'm actually moving my decimal point 1 position to the left, right? Because I'm multiplying by 1/10 or 0.1, right? So I'm going to come up with 0.532, right? Now, for me, it's a nice, easy trick to be able to just move the decimal point which way I need it without thinking too much, right? But the question is, can you get there? All right, go ahead and do the other two. Pause the video, go ahead and try them. Okay, so we have 10 to the minus 2, so I'm going to move my decimal point 2 positions to my left. Well, again, my problem is I have to go and put in a 0.0476 to be able to move my decimal point 2 positions to the left, right? And I will tend to write a 0 out in front of this number, and the reason I do that is because I want to make it very clear there's a decimal point here. It's very easy to miss a decimal point on a piece of paper. You can think of it as maybe it really is a decimal point, or maybe it's just a defect in the paper. Maybe there's a little bit of toner on the paper, so it's kind of hard. So I will typically write my numbers with a leading 0 just to be clear. Right? Here I have to move my decimal point 3 positions to the left because I'm multiplying by 1 over 1,000. So this becomes 0.008. I move my decimal point 3 positions. 1, 2, 3, 4, 4. Realize that doesn't mean there are 3 zeros out here. It means I've moved my decimal point 3 positions. You have to count decimal points. Okay. The format of a scientific notation number, you will notice that this number out here we call it the coefficient. This number out here always has one non-zero digit. Only one, not 2, not 3, not 4, and it has to be non-zero. One non-zero digit before the decimal point. And however many it has after it, that's not important. But there may only be one before it. Okay? And we're always multiplying by 10 to the something, even if that 10 to the something is 0. Right? Doesn't matter. Right? You still have to have the times 10 to the something to have scientific notation. Right? So if we look here, you'll notice we have one non-zero digit before the decimal point. Here we have one non-zero digit before the decimal point. We could have a number like this, 10 to the minus 4. Right? That is a perfectly legitimate number. There is only one digit left of the decimal point because the decimal point is implied to be there. So this number would be 0.0008. Okay. This number would be, let's just go and do these just very quickly. Right? You should be able to do these in your head. 0.0476. This one is going to be 0.000900. This one's going to be 7028.302. Right? All right. So what I would like you to do is I'm going to take a break. You go ahead and pause the video and go ahead and see if you can do these 8 problems, and then turn me back on, and I'll go through all of them with you. Okay, your first one over here is 958. We have to move the decimal point 2 positions to the right, 038. Here we have to move it 4 to the right, 84400. Here we have to move it 3 to the right, 9894.4. Here we have to move it 6 to the right. Now we got to make up a bunch of stuff here, 830000. All right. Now all of these exponents over here are all negative, right? So we're going to have to be moving the decimal point to the left on this one. So this is going to be 0.06504. This is going to be 0.0005. This is going to be 0.0020002. And this is going to be 1, 2, 3, 4, 5, 6, 45. I had to move it 6 positions to the left. All right. Try to convert these to standard notation if you would. Again, give me a break, pause me, and go ahead and work these out. Make sure they're all in scientific notation. Then come on back and I'll do them for you. All right. This one is 14. So that means it's bigger than 10, which means I'm going to have to multiply by 10. I have to multiply by 10 once to move the decimal point. So this is going to be 1.4635 times 10. And the only question is a positive 1 or negative 1? It's positive 1. I move the decimal point clearly 1 position, but I'm multiplying by a big number because I'm making this bigger, so I'm multiplying by 10. So it's 1.46. Here I have to move the decimal point 2 positions, so it's 1.9483 times 10 to the second. Here it's 3.29902, and here I had to move it 2, 4, 5 positions. And here I got to move it a bunch of positions. I think that's 7 positions. Let me count them again. 2, 4, 6, 7. Yep, that's 10 to the 7th. Right? Now over here, I'm going the other way. All right. So again, we have to be conscious of that. We're going the other way. We're multiplying by a small number because this thing is is less than 1. So this is going to be 6.32856. Remember, only one digit, one non-zero digit before the decimal point, times 10 to the minus 1. Here we have to move the decimal point to here, so it's 7.402. All right, remember it has to be one non-zero digit, and we move the decimal point 3 positions. Here we're moving the decimal point 2, 4, 6 positions, so 9.00 times 10 to the minus 6th. You might be tempted to write this as 9 times 10 to the minus 6th. All right. While that is a correct answer numerically, it is not a correct answer with significant digits. And again, you're not being tested on that yet. You're going to learn about sig figs when you're in chemistry. Okay. All right, and here we have to move this stupid thing a bunch of positions. Where am I? All right, there's 2, there's 4, there's 6, there's 8, there's 10. So this is 8 times 10 to the minus 10. So that's a small number. So folks, you need to be able to convert from scientific notation to standard, standard back to scientific, and you need to be able to understand and be able to apply the rules for creating a number in scientific notation. All right, that's it. If you would go and do the worksheet, please make sure you get those right. And then if you have questions, please come see me in class or before or after school. All right, have a wonderful day. I'll see you soon.